In the high-stakes world of technology, the battle for semiconductor dominance has become the new arms race. The United States has spent years tightening sanctions to choke off China's access to cutting-edge chips, especially those under 10 nanometers that power the most advanced AI systems. Yet, against all odds, China appears to be making progress toward 3-nanometer technology, a level of chip-making once thought unreachable without access to Western equipment. How are they doing it? Is it pure innovation, clever workarounds, or the unstoppable force of state-backed funding? Today, we break down the strategies, breakthroughs, and global implications of how China is pushing past U.S. chip sanctions. The U.S. sanctions and the 3-nanometer roadblock in 2022. The U.S. increased semiconductor sanctions against China, restricting access to cutting-edge chip-making equipment and high-performance processor exports. The restriction aims to prohibit China from making semiconductors smaller than 10 nanometers, which are needed for breakthrough AI, supercomputing, and military technologies. Extreme ultraviolet EUV lithography machines, mostly built by Dutch company ASML, are the biggest obstacle to 3-nanometer production. Making efficient, mass-produced 3-nanometer semiconductors without EUV is practically difficult. The US prevented China from buying these equipment by persuading allies like the Netherlands and Japan. This has left China using outdated deep ultraviolet DUV machines, which are less precise and require more intricate multi-patterning to try smaller nodes. Sanctions have delayed China's semiconductor advancement, but they may have generated a technical survival instinct that is propelling innovation at home. Stockpiling and loopholes in sanctions. Chinese enterprises rushed to buy manufacturing equipment before the penalties were completely implemented. SEMIC, a semiconductor giant, has bought dozens of DUV lithography systems to stockpile for years. While not as efficient as EUV machines, advanced engineering can push them to create 7-nanometer devices and possibly smaller with enough layers and processing steps. Chinese companies have used subsidiaries or international partners to source crucial components through supply chain gaps beyond stockpiling. Local equipment companies like Shanghai Microelectronics Equipment (SMEE) are also producing more lithography instruments. SMEE's 193 nanometers and 248 nanometers machines are far from EUV's capabilities, but they support China's self-reliance goal. China's semiconductor sector survives sanctions by hoarding resources and accelerating homegrown alternatives. The big fund and government backing China's government has thrown enormous financial weight behind its semiconductor ambitions. In May 2024, the third phase of the National Integrated Circuit Industry Investment Fund, known as the Big Fund 3, was launched with roughly 344 billion yuan, about 47.5 billion US dollars, to invest in chip manufacturing, materials, and equipment. On top of that, in January 2025, China announced a separate 60 billion yuan $8.2 billion AI-focused fund to accelerate domestic development in high-performance computing and machine learning. These massive injections of capital are designed to create an end-to-end local ecosystem, from research labs to chip fabrication plants, and even to packaging and testing facilities. The funding also includes subsidies for talent recruitment, luring engineers and scientists from Taiwan, South Korea, and even Silicon Valley. This state-backed war chest ensures that companies like SMIC, Huawei, and emerging startups have the financial runway to experiment with next-generation manufacturing techniques, even if those experiments take years to mature. Huawei and SMIC's 3-nanometer ambitions. Perhaps the most significant sign of China's determination is the reported collaboration between Huawei and SMIC to produce a 3-nanometer chip by 2026. This is a bold target considering their current technological constraints. Huawei has been working on gate-all-around GAA transistor designs, a cutting-edge architecture that improves efficiency and performance, and is even experimenting with carbon nanotube semiconductors in lab environments. These designs, if successfully transferred to manufacturing, could rival chips from TSMC and Samsung. The challenge lies in scaling them up. Without EUV, SEMIC will need to rely on complex multi-patterning with DUV equipment, which is slower, costlier, and harder to yield at high volumes. Yet, even limited production of 3-nanometer chips for specialized AI tasks would be a major political and technological win for China, signaling that sanctions cannot fully stop their progress. Workarounds in AI computing. Even without immediate access to cutting-edge chips, Chinese AI companies are finding creative ways to compete. Firms like Tencent and DeepSeek have optimized their AI models to run on less advanced NVIDIA chips, such as the export-restricted H20, by using advanced algorithms and mixture of experts' techniques. These methods reduce the computational load by only activating parts of the AI model when needed, dramatically cutting hardware requirements. DeepSeek in particular has attracted global attention for producing AI models competitive with Western offerings despite using inferior hardware. These efficiency breakthroughs mean China can keep training powerful AI without waiting for domestic 3-nanometer mass production, effectively narrowing the performance gap in software, even if the hardware still lags behind, building a domestic supply chain. China's path to 3 nanometers is not just about chips, it's about everything that surrounds them. Semiconductor production requires a highly complex supply chain involving wafers, photoresist, gases, and testing equipment. Sanctions have made importing many of these materials more difficult, so China has accelerated its domestic manufacturing. Companies like Zhending Technology have reported year-over-year growth of over 30%, driven by the China for China strategy, producing high-quality components domestically for domestic use. This trend ensures that even if international suppliers cut off access, local fabs can keep running. By controlling more of its own supply chain, China reduces its vulnerability to foreign pressure and builds a foundation for sustainable, independent chip making. The sanctions backfire effect. Ironically, the US sanctions designed to slow China's tech rise may be having the opposite long-term effect. While they have caused short-term setbacks, they have also forced China to invest heavily in its own capabilities. In the past, Chinese companies often relied on foreign suppliers for critical technologies. Now, necessity has driven innovation, with startups and state labs working on everything from chip design software to lithography optics. Over time, this could result in a more self-sufficient and resilient Chinese tech ecosystem, one that is harder for sanction to disrupt. The global stakes of a 3-nanometer breakthrough. If China reaches limited 3-nanometer production by 2026, the global semiconductor balance could shift. Even if the yield is low and the cost high, the symbolic value would be enormous. It would prove that US sanctions cannot completely block technological advancement, potentially encouraging other sanctioned nations to follow a similar path. This could also disrupt the dominance of companies like TSMC, Samsung, and Intel, especially in specialized AI markets where China could supply its own needs. On the geopolitical stage, such a breakthrough would intensify the tech rivalry between Washington and Beijing, possibly triggering even stricter export controls or sparking new alliances in the chip industry. The roadblocks ahead. Despite all the progress, China still faces significant hurdles. Producing 3-nanometer chips without EUV means slower throughput, lower yields, and higher costs. Competing with TSMC's mature 3-nanometer process, which already powers Apple's latest chips, will be extremely difficult. In addition, China's electronic design automation (EDA) tools used for chip design are still behind leading Western software from companies like Synopsys and Cadence. Overcoming these gaps will require sustained R&D, international talent recruitment, and possibly decades of incremental improvement. The future of the chip war. The semiconductor rivalry between the US and China is not just about technology. It's about national security, economic power, and control over the future of AI. The US aims to maintain its lead and protect its allies, while China seeks technological independence and global influence. As both sides pour billions into the race, the next few years will be critical. If China's 3-nanometer efforts succeed, even partially, it will mark a turning point in the global tech order. Whether that happens in 2026 or later, one thing is certain: the chip war is far from over. So, can China really beat US sanctions and produce 3-nanometer AI chips without EUV technology? The odds are stacked against them, but history has shown that massive funding, national focus, and relentless innovation can defy expectations. Through stockpiling, domestic manufacturing, AI optimization, and bold partnerships between giants like Huawei and SMIC, China is inching toward that goal. If they succeed, it will not only be a technological triumph, but also a geopolitical shockwave. If you enjoyed this deep dive into the chip war, make sure to like, subscribe, and hit the notification bell so you don't miss our next video. And let us know in the comments: do you think China will hit 3-nanometer production by 2026, or is the US still too far ahead?